The next part here in P7 is going to take what we just did with absolute value, but now try it again with some quadratics. So we've done parabolas before, and you've been able to graph these by hand. So with this here, you've been able to factor something like this before. I would guess that no matter what method you use, you guys are good at being able to get x minus 4 and x minus 1 as factors. And you would be able to tell me then that the zeros would be 4 and 1. So you'd put a dot at 4, you'd put it at 1, and then you could tell me that because there's a positive x squared, that this parabola opens up. Now you're making a sketch, so how far above and below you are, like how deep your U is, or how fast it's going up or down, not going to matter to me. As long as you know it opens up and you have the zeros in the right spot, you are good. So by hand, you could make a sketch of this. But what we're going to do is be able to kind of figure out how could I actually have picked this without knowing that this is a positive x squared. Maybe you don't remember that. There's this thing called a sign chart where all the zeros you get, you put the 1 and the 4, all the zeros on here, and then we're going to do some test numbers where we plug those test numbers into the factors. So given that this is a number line, I'm going to say, what's a number to the left of 1 in the number line? Maybe you pick 0. So if you pick 0, when you plug in 0, you're going to get 0 minus 4 and 0 minus 1. What we care about in a sign chart is what are the signs that show up in those factors. So 0 minus 4 is negative 4, results in a negative. Then 0 minus 1 results in a negative as well. And a negative times a negative becomes a positive. So we know this chunk of the graph has to be positive. And we see that over here. We see that it is above the x-axis, that there's positive numbers up here. Then in the middle, I think, what's a number between 1 and 4? 2. If I plug in 2, I'm going to get 2 minus 4. That's negative. But 2 minus 1 is positive. So if I were to multiply the two numbers like I would with these factors, I'm going to result in a negative number. So this chunk of the graph ends up being negative. And we see that this is below the x-axis. Remember, negatives less than, below. So if we're below the graph, we've got negatives going on. It's less than. Then a number to the right of 4, maybe 5. 5 minus 4 and 5 minus 1 are both positive. A positive times a positive is a positive. We see this is supposed to be a positive chunk of the graph. We are going to need this method later when we've got some more complicated equations rather than just these quadratics. So getting familiar and comfortable with this method, a good investment for later. So I'm asking now in the original problem here, I'm saying where is this parabola less than 0? Well, y equals 0, we know, is right here. Below it is down here. And didn't we just decide that on a sign chart that this whole chunk was going to be negative, that this whole chunk was going to be below 0? We did. So that is why I would say write your interval, your answer as an interval. Starts at 1, ends at 4. And because I don't have the line underneath, I cannot be equal to 0. I need parentheses. We're going to repeat this process again. With this here, I want you to be able to do it without a calculator. So this is what we're going to need to do here. Factoring, that's going to require us to make this actually equal to 0 first. So I'm going to move that negative 5 over. 6x squared minus 13x plus 5 is now greater than or equal to 0. Now the factoring here, you're going to want to do the box method maybe, or the other way, but I'm going to give you these factors here. Make sure you know how you could find these on your own. Getting the zeros from here, setting it equal to 0, I would have to add 5 and divide by 3. All right, the video cut off. I'm not sure quite how much of this it caught, but we made this all to one side, factored it, solved for the zeros, and put them on the sign chart. So now I'm going to find a number to the left here that is 0. So if I plug in 0, 3 times 0 minus 5 is something that's negative. 2 times 0 minus 1, something that's negative. So a negative and a negative will result in a positive. Something between 1/2 and 5/3 is actually 1. 3 times 1 minus 5, negative. 2 times 1 minus 1 is actually positive. So a negative times a positive will result in a negative. After 5/3, something like 2 or 3. Let's pick 2. 3 times 2 minus 5, positive. 2 times 2 minus 1, positive. So the whole section's positive. We can fill out our sign chart. This might help us to say, okay, 1/2 we know to be 0.5. 5/3 is 1 2/3, so 1.67. This is another way to say, okay, I start positive with my parabola, I go negative, and I come back up positive. Then I think about my answer, the interval I want. I want it to be greater than or equal to 0. So greater than, above, I want these two pieces of my parabola. So then I say, okay, I started at negative infinity. I ended out at 1/2. That right here, the stopping point is 1/2. Now, infinities get parentheses, but now that I've got the line underneath, now that it's equal, I want to bracket u. I know I'm going to need the u because I've got to get the second piece. So then it starts at 5/3 with a bracket because I've got the line underneath. Then I am going to do comma infinity to say it goes all the way to the right. It keeps extending. If I go in the calculator and I look at these, clear out the old stuff, I'm going to put 6x squared minus 13x plus 8. I put that in y1. I want to know, where is it greater than or equal to 0? Where is it above the x-axis? It gets close, but it's entirely above the all-axis, the whole axis. So this is always true. This inequality is. It is infinitely many solutions, or IMS. And the interval, we would say, is negative infinity to positive infinity, or you could use the symbol for all, real numbers. If I change it up, though, and now I'm going to have 6x squared minus 13x in y1 and negative 8 in y2, now I'm saying, where is the parabola less than? Where is it below? So where is this parabola below this line? Well, it's never anywhere. So we would say no solution. And then there's no interval. Here's a cubic. This is a preview a little bit as to where we'll be going the rest of this semester. But x to the third minus 3x plus 1. We want to know, where is this greater than or equal to 0? So we were going to need to find those zeros. So remember that that's going to be our second calc 0. So second calc 0 command. So second calc option 2 for 0. Remember, left bound, right bound, we got to think, okay, if I'm going to look for this 0, where it's crossing the x-axis, if I am on the left side of it, is my graph above or below? I could find it below. So I'm going to hit enter. Right bound. To the right of this 0, my graph is above, so I'm going to grab a point up there, press enter, enter again, and it tells me that the 0 is at negative 1.87. So maybe we want to make a list of the zeros. Negative 1.88 if we round. And you could repeat that 0 process, and we're going to get then 0.35, 1.53, and those are the 3 spots where it's crossing the x-axis. So now we're saying, where is it greater than or equal to 0? Where is it positive? This piece right here. So from our negative 1.88 to this 0.35. So I've got the line underneath, again, brackets. Union, I've got from this 0 all the way up. That's where it's positive, where it's greater than 0. So here, up, that's the 1.53 up to infinity, but infinity gets that parenthesis because it's always stuck that way with infinity. So with this here, this problem, we're going to skip it. It's a preview of something we'll do later, but this is something that I want you to be comfortable with, especially moving into chapter 1. We're going to do it a lot. So with P7, there were 2 different days that we were spending on this. This is the first day. It was really the other 2 videos, just 1 to 7 odd. Day 2, this video, matches with 6, 8 to 13, and 15 for your homework. Let me know if you got questions.